Hi everyone, in this video we're going to go through section 10.1. This is the beginning of chapter 10, which is all about hypothesis testing. Throughout chapters 10 and 11 we have 5 sections remaining in the course. It sounds crazy, but those 5 sections all deal with the topic of hypothesis testing. Actually 6 sections, but they all deal with the topic of hypothesis testing. And the first step in completing these doing these hypothesis tests is understanding the language. So we're going to kind of get a glimpse at what the notation and the language that we use during hypothesis testing. Okay, but we start out with what the need for hypothesis testing. And it involves a friend of yours wanting to play a game where you flip a coin. Flip a coin, it comes up head, you win, tails, you lose, or your friend wins. And if you play 5 games and it comes up tails every time, how do you feel about that? Do you think your friend is cheating you? Or are they using a weighted coin? Is that likely? So for example, if the first coin comes up heads, or comes up tails, there's a 1 out of 2 chance, 50% chance. If the second one comes up tails, those two, that is equal to 1/4, or 25% chance. Okay, I don't think they're cheating me yet. How about a third one comes up heads? Right now we're down to 1/8. That's 12.5%. If you keep going, the percent keeps getting smaller and smaller. At what point do you say, I think you're cheating me? You're using a weighted coin, right? So that's kind of where the need for hypothesis testing comes from. How are the results extreme enough for me to draw some conclusion? Are the results of my study, of my sample data, whether it's a mean or a proportion, is it extreme enough? Is it big enough of a difference for me to say, no, this isn't right, something's going on here, there's someone's cheating, basically. So I have at the top of this slide the dictionary and then statistical definition of hypothesis testing, right? It's a proposition assumed as a premise in an argument. In statistics, it's a statement regarding a characteristic of one or more populations, a hypothesis test. So I think when I upload this video to YouTube, half of the students enrolled in this class will actually watch the video, right? That is a hypothesis, okay, in statistics. And then hypothesis testing is the procedure by which we test that hypothesis, right? That's just using the word in the definition. It tests whether or not used to test statements regarding a characteristic of one or more populations. In the steps there, we make our statement about the nature of the population. Half the people that are enrolled in this course are going to watch this video. I hope more than half, but that's the statement that I'm making. And then you collect your sample data, your evidence, to test that statement, okay? And then the data is analyzed to assess the plausibility of that statement, okay? Those are the steps. Okay, and when we do a hypothesis test, we look at 2 different hypotheses. The first is called the null hypothesis. That is the statement that we are testing. It is a statement of no change, no effect, no difference. The null hypothesis is assumed true unless the sample evidence indicates otherwise. And then the alternative hypothesis is the one that you're trying to find evidence to support. The language that we use, like the way that we read this out loud, is H1. H1 is the way that one's read out loud, and this one you can read it as H0. There's nothing wrong with that, but the fancy mathematicians out there read that out loud as H0, N-A-U-T, or maybe it's G-H-T, but I think it's N-A-U-T. It just means H0. Naught means nothing, basically. It's just a fancy way of saying H0. So for the example I gave you just a second ago, my null hypothesis might be that I think that the percent of people that are going to watch this video is 50%, 0.5. And then the alternative hypothesis is, well, we want to test whether it's actually less than 50%. Sadly, we might see fewer than half of the people enrolled in the class taking or watching the video. Okay, so those are examples of null and alternative hypotheses. And we can look at 3 different types of tests, and those are kind of on the right here. I'll highlight them. The first one is a two-tailed test, a left-tailed test, and a right-tailed test. And those terms all involve the tails of our normal distribution, or our t distribution, right? If you're looking at the parameter for your null hypothesis, notice actually first that the null hypotheses, they're the same. They're always that the parameter, the mean or the proportion, equals a number. Always. It's the alternative that changes. You either have a two-tailed test where you say, all right, the alternative hypothesis is that the parameter doesn't equal that number, or the alternative hypothesis is that the parameter is less than that number, or it's that the alternative hypothesis is that the parameter is greater than that number. Okay, so those are the three different changes, there are three different types of tests that we will encounter as we go through these last 6 sections. Okay, and we have to kind of first identify that, because that's going to tell us which, whether we're looking for a positive z-score or a negative z-score or two different z-scores. For this next example, you should definitely pause the video. There's a lot of words here, but you should pause the video so that you can read through each blurb and kind of see if you can figure out ahead of time what the null and alternative hypotheses are, and then whether the test is left, right, or two-tailed. But again, I'm not going to take the time to read these out loud. I think that you can hopefully handle that on your own. For A, the Medco pharmaceutical company, so our null and alternative hypotheses, so we go H naught, a colon, H1, and a colon. All right, we're testing proportions in this problem, and the proportion is P equals 0.02 or 2%. The alternative hypothesis, P is greater than 0.02, 2%. Okay, so first thing, how did I know it was a proportion? Well, there's my percentage. There's the word percentage. Okay, and then how did I know it was greater than? Well, my keyword in A is right here, more than 2%. And because it's more than, this test is right-tailed. Okay, so that is part A. Part B, null hypothesis, colon, alternative, colon. In this one, part B, we're testing means. So we're going to say that mu is equal to, let's see, $56,130. And the alternative, mu, is not equal to $56,130. This one is two-tailed. Okay, so what clued me in this one? Well, there's the word mean price. Anywhere else that they talked about the mean price? No, they did not. Okay, so that's the one keyword that tells me that we're talking about means in part B. And then how did I know that it was two-tailed? Well, there was one single keyword indicating that it's a two-tailed test. Different. Not more than, not less than, just the word different indicates that our test is two-tailed. Part C, this one, we're looking at the standard deviation. So, oops, I forgot my H's. H naught, H1. We're talking about standard deviation in this one, and it's 0.23 versus the standard deviation being less than 0.23. And then this one would be a left tail test. Okay, how did I know that? Let's circle where it talks about standard deviation. Let's see. Here's standard deviation. Less variability. There's more standard deviation. And then I think those are the only things indicating standard deviation. And then how did I know that this was oops, I spelled left wrong. Left. There we go. How did I know that this was a left tail test? Well, it's right here. Less variability. So those words often come at the end. They could be earlier, but you just have to find the key words that indicate what type of test it is. Now, we skip until the end of the hypothesis test for the rest of this. So what we'll look at in the future sections are the actual work involved, right? The beginning of this video has been the setup, the beginning of a hypothesis test. Now, what are the conclusions? What are the outcomes of a hypothesis test? Okay, we have 4 different outcomes, and in a minute, I will compare them to our legal system in America, the different outcomes in a court case, okay? But for now, I'll just read through them. You reject the null hypothesis when the alternative hypothesis is true. That's a good thing. You don't reject the null hypothesis when the null hypothesis is true. That's a good thing. You reject the null hypothesis when the null hypothesis is true. That's bad. That's called a type 1 error. That's incorrect. And then you don't reject the null hypothesis when the alternative hypothesis is true. That's also bad. That's called a type 2 error. So I read them all. You probably have no clue what any of that means, which is why we compare it to a court system. Okay, when you are arrested and you go on trial, you are innocent until proven guilty. And at the end of that trial, there are 4 different outcomes. Okay, 4 different outcomes at the end of a trial. All right, here they are. 1, you are found guilty and you did it. You did the crime, whatever it is. All right. 2, you are found not guilty, and you didn't do it. Those are both good, right? And now reread 1 and 2. Pause the video, reread 1 and 2. Those are the same outcomes, the same scenarios. Reject the null when the alternative is true. Found guilty and you did it. Don't reject the null hypothesis. In this case, in the court system, the null hypothesis is innocent. You are innocent until you're proven guilty. That is our null hypothesis. Okay, so those are the 2 good scenarios. Guilty and you did it, not guilty and you didn't do it. Then number 3, maybe you can kind of already figure out what this one is. You're found guilty. What's the but? Guilty. And you didn't do it. And you didn't do it. Oh no. See why that one's bad? Right? That's bad. That's a type 1 error in statistics. And number 4, the last one, again, maybe you can kind of figure this one out by now. You're found not guilty, and you did it. Did it. There we go. Okay. I'm not sure why all the exclamation points, but not on 2. But we'll go with it. Okay. So those last 2, 3 and 4, are the same at the top, are the same 3 and 4 at the bottom. One is in general in statistics, one is how our legal system works. Okay, and those are the 4 different things that can happen in a hypothesis test. If I have a random sample of my YouTube videos and fewer than half of my students are watching those YouTube videos in that random sample, right, and I reject the null hypothesis that it is half, but it's actually more than half, or it actually is half, that's an example of an error. If my sample data indicates different than what is actually true or what is actually happening. In this next example, again, you should pause the video and read through this paragraph so you understand the setup to the problem, but I'm going to get right into the answers. What would it mean to A, make a type 1 error? Well, that's where you reject the null when the null is true. So we say there is evidence that more than 2% of they were children get headaches as a side effect, but it actually is 2%. Okay, that's the error. The evidence, the sample data says it's more, but it actually is 2%. What would that mean about this new drug? Maybe it doesn't get approved because of this study, but it actually should have been approved. That's why that's called an error, and that's why sometimes studies are duplicated to see if the results are consistent. And then part B, what is a type 2 error? There is not evidence to indicate that it's more than 2%. There is not evidence that it's more than 2%. 2%, but it actually is. It actually is more, right? And that's bad. Maybe the drug gets approved, but it shouldn't because it gives kids headaches more often than is acceptable. Okay, so the probability of error. Error is going to happen. Just like with confidence intervals, a 95% confidence interval, we're very certain, 95% certain that the interval contains our unknown parameter, but we don't know that with absolute certainty, just the likelihood that it does. Similarly, We don't know that our hypothesis test is correct, just the likelihood, the chances that there are an error. And we're only going to look at this alpha, this type 1 error in this class. And that's something that is chosen, that is set by the researcher before they even collect their data. And we refer to it as the level of significance. And we'll see what that looks like in problems as we go along. A word of caution here on this next slide. In terms of writing your answer stating the formal conclusion to a null or to a hypothesis test, it's wrong to use the word except. Just like at the end of a trial, the defendant is never called innocent. It's either guilty or not guilty. Okay, so we either say that we do or do not reject the null hypothesis. Okay, so those are the two phrasings, and we'll look at an example in just a second at how to write these like fancy formal sentences at the end of our hypothesis test questions. Okay, so here we're going to practice writing that sentence, and we've got a study, 2006. The mean length of a phone call is 3.25 minutes. The researcher believes the mean length has increased since then. If our sample evidence indicates the null hypothesis should be rejected, what is the wording of that conclusion? All right, so here's the fancy formal sentence. This is for the first one. There is sufficient evidence that the mean phone call, or the mean length of a phone call has increased since 2006. There you go. That's it. That's the wording. When we get into the later sections, it'll be a little bit more specific. It'll be slightly, a few other words here and there. But that's how you word the answer, the conclusion, when you reject the null hypothesis. There is sufficient evidence to indicate that the length has increased. For the second one there, suppose the sample evidence indicates that the null hypothesis should not be rejected. What is the wording of the conclusion? All right, then here is the phrasing for that. There is insufficient. A word that, if you don't like the word sufficient and insufficient, there is enough or not enough. Like if you don't like all this fancy language, there is insufficient evidence to indicate the mean length of a phone call has increased. Increased since 2006. Boom. There we go. Okay, so there's two examples of the phrasing. We'll write these sentences a whole bunch of times. Hopefully you'll get pretty good at it. It's kind of a canned response. You just pick part of the sentence is whether there's enough or not enough evidence, and then you go back and use some of the wording of the problem, and then you just kind of figure out where to pull the different parts of the sentence from. Okay, that is the end of this section. Thank you very much for listening. Work on some homework problems. Let me know if you run into any difficulties, and have a wonderful day. Thanks.